Excellencies, distinguished guest participants, ladies and gentlemen.
Before the event begins, we would like to inform you the conference etiquettes. 1. Participants must keep their mics muted during the event. 2. Participants can turn on their cameras during the event.
Third, customize the display name in Zoom with the format for speaker, S_name, moderator Mo_name, steering committee SC_name, and organizing committee OC_name.
And I would like to repeat the conference etiquettes. 1. Participants must keep their mics muted during the event. 2. Participants can turn on the cameras during the event.
Third, customize the display name in Zoom with the formats for speaker S_name, for moderator Mo_name, for steering committee SC_name, and for organizing committee OC_name.
We do hope all of our guests, participants will follow today's conference etiquettes for the sake of today's event to run smoothly.
To all speakers, all moderators, all sponsors, all committee, and distinguished participants, good morning, ladies and gentlemen. Live from Bandung, Jatinangor, Indonesia, here we are welcoming you to the second
Virtual Mobility Program 2022.
Okay, my name is Amelia Safira, and
I am Nova Ramadan.
Will be the master of ceremony at this event.
Before we start today's event, let's bow our heads for a moment to pray according to our personal religion and beliefs and wish for the event to go well and smooth.
Prayer starts now. Over. Before we begin, we would like to show you some clips that we've prepared. For the operators, you may proceed.
Dalam membuat batik tulis, ada beberapa tahapan yang harus diketahui. Berikut tahapan membuat batik tulis yang telah dirangkum budaya Indonesia. Batik tulis adalah batik yang dibuat di mana canting dipakai sebagai pen untuk menulis atau menggambar. Canting biasanya terbuat dari kayu yang ujung gagangnya terbuat dari kuningan atau plat seng dan berbentuk lancip. Canting biasanya dimasukkan ke dalam wajan yang berisi lilin malam yang nantinya digunakan sebagai tinta untuk menggambar. Setiap sehelai kain batik tulis yang dihasilkan tidak hanya dihasilkan oleh seorang perempuan yang duduk sambil mencanting saja. Biasanya terdapat jasa 4 hingga 5 orang dalam mengerjakannya, yang kebanyakan bukan dikerjakan di pabrik, melainkan industri rumahan yang memainkan peran utama dalam mengerjakan proses membatik ini. Berikut ini adalah tahapan membuat batik tulis yang berhasil dirangkum untuk Sobat Budaya Indonesia. Tahap pertama disebut nyungging, merupakan kegiatan menggambar motif atau pola batik pada secari kertas. Karena tidak semua orang bisa menggambar motif batik, sehingga dibutuhkan keterampilan khusus seseorang dalam melakukannya. Tahap kedua adalah japlak atau jiplak, merupakan kegiatan memindahkan gambar dari kertas tadi ke dalam kain yang akan digunakan sebagai bahan untuk membatik. Tahap ketiga disebut ngelowong, adalah proses menempelkan lilin malam di kain dengan media canting, di mana pada proses ini motif batik akan mulai terlihat. keempat adalah nyiseni, merupakan proses untuk memberi isenan atau isian atau yang populer dengan mengisi motif pada kain sesuai gambar motif yang sudah digambarkan di tahap pertama. Tahapan ini juga menggunakan media canting. Tahap kelima disebut nyolet, adalah proses mewarnai pada bagian-bagian gambar motif yang terlihat sering seperti kembang, bunga, dan lainnya. Tahapan keenam disebut mopok, adalah tahapan dengan menutup bagian yang dicolet dengan lilin malam yang juga diiringi dengan proses nembok atau menutup dasar kain yang tidak diwarnai. Tahap ketujuh adalah ngelir atau tahap di mana proses pewarnaan dilakukan secara menyeluruh pada kain. Tahap ke-8 disebut ngelorot, adalah tahap pertama dalam meluruhkan warna lilin malam ke dalam air yang mendidih. Tahap ke-9 adalah ngerentesi, merupakan tahapan memberikan titik pada garis-garis ornamen utama dengan digunakannya canting kecil dan halus sehingga hasil titik yang dibuat terlihat rapi. Tahap ke-10 disebut nyumri, adalah proses menutup kembali beberapa bagian dengan lilin malam. Tahap ke-11 adalah nyoja, merupakan proses mencelupkan kain dengan warna sogan atau coklat yang merupakan warna khas dasar batik asli Jogja atau Solo. Tahapan ke-12 adalah ngelorot, merupakan proses terakhir dalam meluruhkan lilin malam dengan menggunakan air mendidih. Demikian tadi Sobat Budaya Indonesia, kita telah membahas bersama tentang 12 tahapan dalam membuat batik tulis yang sering kita jumpai di pasaran. Siapa yang tak kenal daerah Jawa Barat? Daerah yang terkenal dengan wisata Kebun Raya Bogor atau Telaga Kawah Bodas. Masyarakat Jawa Barat dikenal sebagai masyarakat yang bersifat religius dan diplomatis. Mereka memiliki warisan budaya yang kaya dan nilai tradisional yang agung. Asas dasar warga Sunda atau Jawa Barat adalah Cena Herang Lautna Beunang, atau yang berarti mendapatkan apa yang diinginkan tanpa menyakiti siapapun. Asas ini mendorong rasa saling memahami, gotong royong, dan saling menguntungkan antar warga anggota masyarakat. Tapi tahukah teman-teman, kalau di Jawa Barat juga ada batik? Ya, batik di Jawa Barat berkembang bersama dengan daerah-daerah batik lainnya pada akhir abad ke-19. Batik dibawa oleh pedagang dari Jawa Tengah. Kini banyak orang yang sudah mengembangkan gaya batiknya sendiri dan belajar membuat batik di daerah ini. Batik Hokokai dari Pekalongan terkenal karena motif bunga dan kupu-kupunya yang merupakan pengaruh kuat dari Jepang. Sebagai salah satu ikon batik Jawa Barat, batik ini pada umumnya terinspirasi dari motif kimono Jepang dan menyebar hingga wilayah pantai utara Cirebon di Jawa Barat selama masa penjajahan Jepang yang singkat terhadap Indonesia silam, yakni pada tahun 1942 hingga 1945. Ada beberapa motif batik Jawa Barat, antara lain motif batik Megamendung. Motif ini konon diciptakan oleh seorang raja di masa kerajaan Padjadjaran yang mendapatkan ilham melalui meditasi untuk mendapatkan petunjuk Tuhan untuk mengatasi pergolakan. Kata mega berarti sinar matahari atau sinar mentari, sementara mendung merupakan awan yang menutupi terik matahari. Motif awan ini menyiratkan kemampuan untuk tetap tenang dalam segala situasi dan kemampuan untuk menjadi pimpinan yang mengilhami dan berbudi tinggi, yang melindungi warga dan memenuhi kebutuhannya. Ada pula motif batik Sinaran. Motif ini berasal dari Cirebon. Merupakan gambaran cahaya yang menyinari bunga di taman. Cahaya tersebut melambangkan pengetahuan dan pemahaman spiritual yang mendalam, yang memungkinkan kita memandang segala sesuatu dengan positif. Sedangkan bunga-bunganya melambangkan kemampuan untuk menghargai dan bersyukur segala hal terkecil sekalipun. Ada pula motif batik Banji. Motif Banji merupakan stilisasi motif swastika dari India yang masuk ke Indonesia melalui Tiongkok. Nama Banji berasal dari istilah bahasa dialek suku Tionghoa, Banzi, yang secara harafiah berarti 10.000. Sedangkan swastika itu sendiri merupakan simbol spiritual yang telah diadaptasi oleh kebudayaan Tiongkok. Banji melambangkan keberlimpahan dan keterhubungan spiritual segala hal yang ada di alam semesta. Motif ini dimaksudkan untuk menjaga kemurnian spiritual penggunanya dan melindunginya dari macam mara bahaya.
Gazing out my rounded rectangle for the earth of beauty, this is my home and my place. The slow zoom, that house is much bigger than it looks.
Inside and outside the country are welcome to attend presenters and audience member.
Okay, the second virtual mobility program 2022 is in collaboration with Faculty of Agro-Industrial Teknologi Padjadjaran University,
Research Center Biomaterial BRIN,
Research Collaboration Center Biomass and Biorefinery.
and Safe Network ICA Pacific.
And so, before today's main event starts, I want to review the past 3 days event. So in our first day, we had some interesting topics about biomass utilization in food and energy production, considering the ethics of agriculture and biomass engineers. Also, we learned about green technology in biomass and biorefinery. And for the second day, we had some topics about functional food and its innovative product development process. And also we got an interesting section about food structure and its kinetics of food digestion and the bioavailability of nutrients.
Last but not least, on the third day, we had some topics about biorefinery concept by sugar platform, utilization of biomass towards sustainable energy, recent finding of chemometrics in food science, and many more. Wow, it's been such an interesting journey, huh?
Yep.
And we're really excited to look further for the next agenda, and we hope that all participants will feel through the excitement.
Ladies and gentlemen, now we have come to our main agenda, the workshop session.
The session will talk about quality in enhancement of oil palm trunk as sustainable research for wood-based industry. Our moderator for this session is Dr. Puspita Nurlilasari.
Allow me to research.
Located at an altitude of 768.
Dr. Puspita Nurlilasari is a lecturer and researcher, also received her Ph.D. in chemical engineer from 10 November Institute of Technology. She is now lecturer and researcher at Agro-Industrial Teknologi Padjadjaran Universiti. Her activity is mainly devoted to the application of electrocatalysts in renewables from materials transformation and biomass waste utilization, with particular emphasis on nanoparticles to produce oxygen reduction of Myrtha air. Her area of expense are in electrochemical process and bioprocess, scale-up, and agro-industrial plant.
To Dr. Puspita, you may proceed.
Okay, thank you for Amelia and Naufal. Good morning, everyone. I'm very happy and pleased to be invited as one of moderator in the second virtuality mobility program. This mobility program theme is utilizations of biomass towards sustainable food, energy, and biomaterial, which is held by FTIP, BRIN, PKBR, and SAFE Network. Honorable ladies and gentlemen, in this morning, we have great speaker, Mr. Dr. Seng Hua from Department of Wood Industry, Universiti Teknologi, Malaysia. Before we begin, let me introduce Dr. Seng Hua. Now, Dr. Seng Hua is senior lecturer in Department of Wood Industry, Universiti Teknologi, Malaysia. He received his Ph.D. in Wood Science and Technology from Universiti Putra, Malaysia. And recently, in 2021, he got honor in International Innovation Awards with silver medal from Malaysia Technology Expo 2022. Also, he has international recognitions as Outstanding Reviewer Awards from Tech Science Press USA. He published more than 120 journal and 20 chapters in books with more than 1,600 citations. He also associated editor for Frontier in Material, and he also editor for Wood Science and Forest Product. So I would like to invite Dr. Seng Hua to attend here. Hello, Dr. Seng Hua. How are you today?
Hi, good morning. Thank you, Dr. Puspita. Can you hear me?
Yes, I clear
okay.
your voice clearly. Thank
Thank
you,
you.
Dr. Seng Hua, for your willingness to attend our agenda today. I really appreciate it. We have 45 minutes for your presentations and followed by 15 minutes for discussion sessions.
Okay.
And participant, if you have any question or would like to have any question for Dr. Seng Hua, please don't be hesitate to ask him kindly to raise hand feature or write down your questions in the chat box feature in these Zoom applications. Well, ladies and gentlemen, I would like to invite Dr. Seng Hua to give presentation on the title of the quality enhancements of oil palm trunk as a sustainable resources for wood-based industry. Dr. Seng Hua, now time is yours, please. Thank you.
Okay, thank you very much. But can you let me share my screen because I have made some amendment on my slide.
Okay, operator, can you please help about these technical issues?
Okay, yes, okay. Can you see my screen?
Yes.
Okay. So thank you very much, everyone. Thank you for having me. So I will start now. So good morning, everyone. My name is My name is Lee. I'm from Universiti Teknologi Mara, Pahang branch. And today I would like to present a topic titled Quality Enhancement of Oil Palm Trunk as a Sustainable Resource for Wood-Based Industry. So this is my presentation outline. So we will talk about the introduction, the history and origin of the oil palm and the type of oil palm biomass, and oil palm trunk as an alternative resource for wood-based industry, and the imperfection of oil palm trunk. And then we will talk about the quantity enhancement of oil palm trunk, including sowing, drying, and resin treatment. So resin treatment will focus on two different products. One is lumber-based, and the other one is veneer-based products. And then conclusion. So the oil palm, a little bit introduction on the oil palm. The oil palm is originated from the West Africa, and where the evidence of its use as a stable food crop dates as far back as 5,000 years. While palm oil was very common in West Africa, the use of palm oil in the international market expanded significantly as a result of the British Industrial Revolution and the expansion of overseas trade. From candle making to industrial lubricant, palm oil was a driving force behind the expansion of the industrial production, while nutrient-rich red palm oil became a vital asset on a long seafaring voyage. And it was a result of this increased demand that Europeans began investing in palm oil production, first in West Africa, and then expanded to Southeast Asia. A combination of European settler and entrepreneur seeing the opportunity for commercial palm oil production to produce soap, lubricant, and edible oil led to a dramatic expansion of oil palm plantation throughout Africa and Southeast Asia. The first commercial scale plantation in Malaysia was founded in 1917 and established in Kenamaran Estate in Selangor. So oil palm forage in the humid tropics and produce high yield when grown 10 degrees north and south of the equator. Currently, oil palm is cultivated in 43 countries throughout the world, with Malaysia, Indonesia, and Nigeria being the most planted country. Among these, Indonesia and Malaysia are the world's largest palm oil producer. Oil palm tree became productive, especially in Southeastern Asia, since most of the disease and insect that affected African crops were absent in this region. So the graph shows the oil palm planted area in Malaysia from 2013 to 2021. So at its peak, which is the year of 2019, Malaysia planted with 5.9 million hectare oil palm trees. And now in 2021, it has been shrinking slightly to 5.74 million hectares. So this is the type of the oil palm biomass. So oil production accounts for just about 10% industry overall biomass. The other 90% are primarily in the form of lignocellulosic biomass. The palm oil industry produces large amount of oil palm byproducts biomass, such as the residue from oil palm meal that comprise pomade, pressed fruit fiber, AFP, MD fruit bunch, and shell. So in contrast, the byproduct from plantation consists of oil palm frond and oil palm trunk. It is estimated around 75% of the oil palm residue consists of oil palm trunk and oil palm frond, in which this biomass can be directly extracted from the plantation site. So whereas pomade, palm shell kernel, mesocarp fiber, and AFP, MD fruit bunch, that account for the remaining 25% are obtained after palm oil extraction from fresh fruit bunch at the mill site. Okay, the table shows the availability of oil palm byproduct in Malaysia. Usually the amount of AFP, the MD fruit bunch discharged from palm oil refinery is up to 7.78 metric ton per year. The most abundant oil palm plantation residue is oil palm frond here. We have with a value of 23.39 metric ton, while oil palm trunk is 3.74 metric ton per year. Oil palm frond is available daily when they are sheared during the fresh fruit bunch harvesting for palm oil production. So the abundance of oil palm frond has led to this lignocellulosic fiber being used for ruminant like stock feed, palm paper production, biochar production, bioethanol, as well as for erosion control, soil conservation, and ultimately the long-term benefit of nutrient recycling of oil palm plantation. Our topic today will be focused on the application of oil palm trunk. So owing to the vast availability of oil palm trunk, it is therefore a promising alternative resources for wood-based industry. So oil palm trunk has four main parts that can be seen from its trunk's cross section. So first, the cortex with the bark here, the cortex with the barks, and the peripheral region, we refer to it outer region, and the central zone or the middle zone, and the pit zone inner. So the part of the trunk inside the bark, inside the bark is called cortex, which consists of ground tissue parenchyma and vascular bundle, and has a width of 1.5 to 3.5 centimeter, making it a very narrow section. So after the cortex comes the outer peripheral zone, or we call it outer zone, where narrow layer of parenchyma and vascular bundle are found. The high amount of vascular bundle in this region provide mechanical support to the OPT, the oil palm trunk, due to the existence of a high number of radial extended fibrous shapes. So the center and the middle zone here of the oil palm trunk is made up of the larger vascular bundle that are scattered across the thin wall, whereas the inner zone, the vascular bundle are wider and randomly scattered. Both of the middle and inner zone combined make up about 80% of the oil palm trunk. So in the production of oil palm, the trees are capable of producing fruit up to 25 years, after which the productivity of the trees would significantly drop due to aging. So in the oil palm management practice, the old trees are usually cleared up and younger saplings are replanted on the clear land. So in response to the zero burn policy, the oil palm trunk was simply felled using an excavator and chipped to a smaller piece, or chipped or stretched to a smaller piece using a chipping bucket and piled up between the planting row and left to rot. So another common method in the zero burn technology is known as the underplanting method. This method employs replanting of new oil palm sapling under the old palm sapling, which are gradually poisoned. So the old tree has been poisoned, and however, the poisoned palm biomass takes up to 2 years to completely decompose. It needs 2 years to completely decompose, and this 2-year window period open up the oil palm plantation to a complication related to pest incident. So the decomposed oil palm trunk will attract the pests and insects. So other drawback with this zero burn method are that the presence of this huge waste biomass on the plantation will inhibit the proper access for the worker for replanting and subsequent field maintenance works. So you can see the rotten standing tree is still there. So and then in the 2 years time, it will disturb the access of the site for the workers. So, or instead of leaving the trunk and left it rot on the site, we can harvest and convert the tree to logs, and then convert it to value-added products such as lumber and plywood. And this can replenish the wood-based industry that currently facing raw material shortage. So according to a study, a 25 years old oil palm tree has 8 to 12 meters in height and 40 to 45 centimeter in diameter, and it has an estimated 1.7 meter cube grain volume. So based on the harvesting rate of 200,000 hectares per year and 130 trees per hectare, there will be a 26 million trees available annually. So the estimated amount of woody material available will be around 44.2 million meter cube per year. And this vast amount of biomass would be a good supplement to wood-based industry. So here is the opportunity of using the fell of oil palm trunk. The fell oil palm trunk can be converted into lumber-based products or veneer-based products, which has their respective pros and cons. And here we compare the pros and cons between the lumber-based product and the veneer-based products. So for the lumber-based products, the technology is not ready. So current processing process need to be modified to suit oil palm trunk feature, and it has a very low recovery. But for the veneer-based product, the technology is ready. The process sequence is very close to the conventional plywood manufacturing with acceptable recovery. So, and it means that any plywood industry that can directly adopt the oil palm trunk and using the peeling process to obtain the veneer. And the potential products from the lumber-based products is a different category, such as the sawn timber, laminated board, building joinery, and carpentry. And on the other side, for the veneer-based product, include the veneer, the plywood, and the laminated veneer lumbers. So the application for lumber-based products include the furniture, flooring, engineered wood, while the application for the veneer-based product is the concrete formwork, furniture, flooring. And the limitation for the lumber-based products is need a dedicated method for sawing and drying, and it is less stable. Variation is quality due to the density variation throughout the trunk height, and needs special resin treatment in order to enhance the surface quality and strength property of the wood. However, the limitation of the veneer-based product is require modified veneer drying method and also needs special resin treatment in order to enhance the surface quality and strength properties of the plywood. And actually, it would be a beneficial for the fell oil palm trunk to be used to replenish the local plywood industry. Here is a scenario provided by a local plywood manufacturer. So according to the local manufacturer, plywood mills need a minimum resource capacity of 16 million meter cube to operate, to produce about 4 million meter cube of plywood annually. However, only 4 million meter cube timber extracted from the natural forest or plantation resources are available annually. So it means that a deficit of 12 million meter cubes. So efficient utilization of oil palm trunk is very crucial for sustaining the plywood industry. And how much do the plywood mill needs? So the oil palm trunk plywood industry, if there are 26 million trees available annually, and each tree generates 1.7 meter cube green woody material, so it is estimated that 44.2 million meter cube of log are available annually. So if we extract only 80% of the total of oil palm trunk log, about 35.4 million meter cube of oil palm trunk logs are available for the plywood industry annually. Since we only take 18 feet long of the log, only 42% or 14.9 million meter cube will be extracted out. But this 14.9 million meter cube is more than enough to supply for the plywood mills in Peninsular Malaysia that require 12 million meter cube of wood. So, however, before it can be used effectively, there are some shortcomings of the oil palm trunk and lumber that has to be overcome. But first, it has a green moisture content of up to 300 to 500 degrees and density of 200 to 700 kilogram per meter cube. And oil palm wood is also extremely hygroscopic material that absorb and dissolve moisture from surrounding tissue and result in changes in the dimension of oil palm wood. So the extremely hygroscopic nature of the oil palm wood cause a high rate of shrinking and swelling compared to wood. Poor mechanical properties are one of the unfavorable properties of oil palm wood too. And another drawback that limits the utilization of oil palm wood is that it requires a very long drying period since it's possesses very high moisture content. Also, it is very prone to insect and fungi due to its high sugar content. And we can see here the oil palm wood extracted from the oil palm stem has a very low strength and uneven density. And we can see here the center here is very low density, and it had after drying it's a very uneven form. And secondly, it has a very poor machining characteristic. We can see many waves grain here. And the oil palm wood also is very low, has very low durability against the termites and fungi. And it has the more important thing, it has several drying defects. So when it's dry, it will some drying defects, some as cracking, cupping, and honeycombing occurs to the oil palm lumber. And all this is inhibit the oil palm wood to be used effectively. So therefore, quality enhancement treatment are necessary here. So here we divided into two categories based on the products, which is lumber products and the veneer-based products. So in this section for the lumber-based product, we will discuss on the quality enhancement of lumber-based products from oil palm trunk. So before treatment, sowing and drying of the oil palm trunk is very important too in order to obtain oil palm wood with qualities. So first, we were talking about the sowing of the oil palm trunk and lumber. So oil palm lumber has a wide range of grain, moisture content, and density. So therefore, there are two different methods in segregation of the oil palm lumber, which is by density and moisture content. Segregation by density can be categorized into three different parts: the inner zone, the central zone, and the peripheral zone. Segregation by the moisture content, on the other hand, can differentiate between inner and outer portion. Characteristic of the inner part have the MC above 200%, while the outer part has an MC below 200%. So when sowing the oil palm trunk, it is advisable to take this matter into consideration. Therefore, processing needs to be strategic by using a different cutting pattern than tropical lumber. Sowing technique of oil palm lumber is not like other timber products. There is a need to segregate the oil palm lumber into inner part and outer part, as the highest quality is the outer layer that only covers 30% of the oil palm log. So this is the sowing pattern. As we said just now, the outer part of the oil palm trunk, has the best properties. It represents around 30% of the log volume. And then the conventional live sowing techniques such as live or plain sowing are designed based on the hardwood and softwood species. So due to the production priority, the hardwood reside in the core, while the sapwood is found at the periphery of the lumber. So in contrast, for oil palm trunk, the sowing pattern intended for the outer portion, and it is the best property. So it's totally different with the tropical lumber, where the bad part, where the tropical lumber has the best part in the core layer, but the oil palm has the best part at the outer layer. So therefore, a different sowing pattern is needed to fully utilize the oil palm lumber. The oil palm lumber for the inner and outer portion of the trunk. So addressing the sowing pattern issue, Baca et al. Had found that a polygon sowing pattern is the best method to adjust the inner and outer portion of the oil palm lumber. It can produce white outer lumber that are high in qualities with a recovery of 30 to 35%. However, good quality lumber from polygon sawing needs for oil palm trunk to be on the carriage many times, and since the angle of rotation is not 90 degrees, so the polygon sawing is difficult to operate and require a skilled operator. Therefore, a simpler sawing pattern needs to be constructed that can be used by moderately skilled worker without any modification to the existing sawing machine. So for that reason, Baga et al. In 2014 has proposed a new sawing pattern called reverse cant sawing. This sawing pattern is designed especially to maximally obtain the best outer portion of oil palm wood while shortening the sawing time with high recovery, since when sawn timber from the outer part of OIPT can be directly used. So after the sawing, now we come to the drying. So initial drying is an essential step for oil palm trunk to be used effectively as lumber. So initial drying of oil palm trunk could offer several advantages, such as lighter weight or cheaper material transportation costs, better durability against staining, reduced defect of the resultant products, and easier trimming due to better dimensional stability. However, the extreme moisture variant between the oil palm trunk required the trunk to be dried using a drying schedule that is different to the normal wood. Therefore, drying of oil palm trunk and lumber is a very challenging task. So normally, air drying and kiln drying are employed to dry oil palm trunk and lumber. So nevertheless, air drying and kiln drying of the oil palm lumber resulted in unsatisfactory result. The different drying properties between inner and outer part of oil palm lumber proved to be a difficult aspect to tackle. So here, 4 different drying methods are discussed. The drying method include the air drying, the forced air drying, a superfast drying, and a modified superfast drying. Generally, air drying refers to a drying process in which wood is exposed to open air. So while forced air drying involves the employment of the propeller fan to provide a constant flow of air. So on the other hand, the superfast drying method involves drilling some holes in the oil palm lumber and applying light compression to produce the defect-free board. This process requires high precision, as the method for the inner portion and outer portion are different. So the first drying method, air drying. Air drying is the drying of timber by exposing it to air. The technique of air drying consists mainly of making a stack of stone timber on raised foundation in a clean, cool, dry, and shady place. The rate of drying largely depends on climatic condition and on air movement. For successful air drying, a continuous and uniform flow of air throughout the pile of timber needs to be arranged. This is a method of drying timber by exposing it to a natural atmospheric condition. So therefore, it's no control over the drying rate, as this will be determined by the weather. So it will take a very long time to be dry. And then the forced air drying can be defined as the drying wood using accelerated airflow to reduce the moisture of lumber. Here we put an industrial fan here, and the airflow can be accelerated using a fan and create an air movement through the space between the wood. So the 3 factors such as temperature, humidity, and air velocity can be manipulated to control the drying process and minimize the drying defects. So air velocity here has several important implementation reasons, such as to transfer the moisture away from the lumber, and to transport the heat to the lumber, and to give a uniform relative humidity and temperature throughout the drying process. And this is the comparison between the drying rate between air dry and forced air drying. So using forced air method, the inner oil palm wood, oil palm lumber with 3 centimeter and 5 centimeter thickness could attain target moisture content of 60% at day 11 and day 16. Day 11 and day 16. As for outer oil palm lumber, it requires 10 days for both 3 cm and 5 cm oil palm lumber to achieve target MC of 60%. So in comparison to the air dry method, post-air drying greatly reduced the drying time needed. It would take 28 and 29 days for 3 centimeter and 5 centimeter inner oil palm lumber to achieve target MC of 60%. So in comparison to the post-air drying, is air drying method requires 16 days more longer time to attain the moisture content of 60%. So this is another apart from the air drying and the forced air drying. So Baca et al. 2016 introduced an oil palm wood super fast drying method with a reduced drying time to dry oil palm lumber. This method involved drilling hole in the lumber for faster evaporation rate of lumber. It was reported here. So before with the drying, we will do a holing here. The oil palm lumber, we will do some different holings, and then we will subject it to a direct contact drying using a hot press, using a different according to a different part of the lumber. For outer layer, outer oil palm wood, the temperature used is 180 degrees and apply a 20% compression. And for the inner, there is a 2 cycle of direct contact drying. So because inner has a very much higher moisture content, so it requires 1 more drying cycle. So after both the direct contact drying, so the oil palm lumber will be subjected to the oven drying, the high temperature drying in oven at 100 degrees Celsius for 3 hours. And then we have took maximum of 3 hours. And then the oil palm lumber will be successfully dry. However, although the super fast drying method can dry the oil palm wood in a relatively shorter time, but it requires holing in the surface of oil palm lumber. So it's unfavorable when the lumber is to be used in the construction. So a preliminary study demonstrated that the oil palm lumber can be dried using super fast drying without hole, provided the initial moisture content of the green oil palm wood is lower to less than 200%. Therefore, in this study, the initial moisture content of the outer and inner oil palm lumber were reduced by using forced air drying method prior to dry using super fast drying method. So the new method, a combination of the forced air drying and the super fast drying method, are called modified super fast drying method. So the modified super fast drying method consists of 2 stages. The first stage involved the drying of oil palm lumber to an immediate temperature of immediate moisture content of 60, 80, and 100 using forced air drying method. And the second stage involved the drying of oil palm lumber from intermediate moisture content to final target moisture of less than 10% using super fast drying method. By using this modified super fast drying method, the holing process in the super fast drying method could be eliminated, or has employed a semi-holing process where the hole are not fully drilled through the oil palm lumber sample. So in that case, at least one surface of the sample remains clear and hole free. So another surface with hole could be hidden during the lamination process. So this is the drying rate of the modified super fast drying of oil palm method. So the super fast is a combination So we can see that it's required around 3 to 5 hours to reduce the temperature of the oil palm lumber to less than 10%. And visual appearance of the oil palm lumber dry with the super fast drying and modified super fast drying method are shown in the figures. So from the figures, we can see that there's no visible drying defect was detected during the drying process for both inner and outer oil palm lumber. So, but for the super fast drying method, like we mentioned before, it required the holding on the oil palm lumber before it was dry. So we can see that the holes here, and it will be inhibits it to be used effectively in the lamination process. But for the modified super fast drying method, there's no holes in the drying process, so we can see that there is no visible defects on the dried samples. And if we compare with the air drying method, we can see that the air drying method has a very severe drying defects here. So after drying, we will talk about the resin treatment, impregnation and impregnation. So impregnation of modified wood is defined as any method that result in the filling of wood substance with an inert material, or we call it impregnant, in order to bring about a desired performance change. So initial experiment using wood veneer by applying impregnation with a phenol formaldehyde resin, heat and compression was implemented, leading to the production of products called impact and compact. The main difference between the impact and compact is the application of compressive force before and during the curing process of the ladle. So it means that the compact means that after impregnation, the compression will be applied to the products. So here is the schematic figure of the impregnation treatment. So the timber will be loaded into the chamber, and then vacuum and empty cell of the air from the timber, and then the cylinder is flooded with the resin, and then we apply the pressure, and after that we will apply another vacuum to extract the excess resin, and then let the timber to dry. So this is the very common resin treatment method in industry. And similar to other impregnation modification technique, treatment with resin create bulking effect, as the cell wall is set is a permanent soiling state when resin molecule polymerize within the cell wall. So heat curing remove the solvent, remove the water, and also result in the polymerization of the resin monomers and oligomers. So the polymerization causes the resin to become insoluble in water and is permanently fixed in the wood structure. So, and it provides the changes in properties of the oil palm lumber, oil palm wood. So after impregnation and curing process, we can see that this is the resin was seen located in the parenchyma tissue, and the treatment significantly improve properties, appearance, and can be used for hybrid furniture and housing material. So impregnation of PF into the oil palm trunk enhance the dimensional stability, and also display the impregnated oil palm trunk also display good mechanical properties. And it's apart from that, it also has a better machining properties. In a study, it's shown that the planing quality improved from grade 3 to average to grade 1, excellent. So that is about the impregnation. So we have conducted a research on using on the quality enhancement using the impregnation. So the patent name is a method of making compact plywood. The process involves a 6-step procedure which include the first one, the solving, and then steaming and compression, and then drying, and then resin soaking or impregnation, and then heating, and the last one is hot pressing for densification. So initially, so how it's worked, that's step one for the sowing. Initially, the palm trunk or log is obtained from the palm tree. So the diameter of the palm tree must be more than 30 centimeter. The palm is then sown to obtain palm lumber using sowing machine with a thickness in the range of 2.5 cm to 4 cm. So this palm trunk is cut or sawn according to the modified current sowing pattern. And then we will using the sowing method, we will segregate the outer layer and the inner layer of lumber for further processing for the step next. So for next, we will have the lumber segregated as the outer part. So the outer part and inner part will be subjected to different steaming and compression schedule. So the first one, for the outer part, we will compress using 10 minutes to achieve around 20% compression level. And for the inner part, it will be compressed using hot press for 10 minutes to achieve around 30% compression level. And then after that, the compressed lumber will be subject to drying. The step involves drying the lumber in a can at a high temperature of between 110 to 150 until reaching a target moisture content between 20% to 40%. The drying is conducted without any drying defects such as split, crack, and warping. So the micro cracks from the previous step we used the pressing, the compression, it will create some micro cracks and it will facilitate the drying process. And then after the drying, the sample will be impregnated for 10 to 20% with phenol-formaldehyde resin with 15 to 20% content. So the physical properties such as waterproofing and dimensional stability will be enhanced. The impregnation step could also increase the durability, strength, and the weathering resistance of the produced compact palm wood. So after that, the next step, the impregnated sample will be heated again in the oven at 100 degrees Celsius for around 3 hours to achieve a moisture content of 60 to 70%. And the last step will be the densification. So the semi-cure, after the heating in the oven, the sample will become semi-cure and it will be compressed by a hot press at 150 degrees to final thickness for 30 to 40 minutes. And this is the untreated oil palm wood before the treatment. And after the treatment, we will get the treated oil palm wood and the compact oil palm wood. And this compact oil palm wood has excellent dimensional stability, mechanical properties, and biological durabilities compared to that of conventional wood intended for exterior application. So now we proceed to the veneer-based products. So veneer-based product here, we refer to mostly to the plywood. So the chemical treatment of veneer with phenolic or equivalent resin polymers or other chemicals, on the other hand, is to enhance the quality of the oil palm veneer and the resulting plywood. So it is anticipated that the loosely bound parenchyma tissue will absorb the chemical, and once it's cured, it increases the density. So as a result, the density gradient within the veneer is reduced, and therefore a stronger and more stable plywood can be produced. So here is some overview of the works done on the enhancement of oil palm trunk plywood via phenolic resin treatment. So we can see that there are different methods and variables. So some with research, they use the veneer pre-treatment. They soak the veneer in the phenol-formaldehyde resin for 20 seconds. And then they discover that the plywood made from the outer layer veneer has an improved modulus of rupture, modulus of elasticity, shear strength, and dry shear strength and wet shear strength. And the plywood made from inner layer veneer also display significant improvement and also display improvement in the moisture modulus of rupture, modulus of elasticity, also dry and wet shear strength. And another study also using the same method, and it found that increment in the resistance against termite attack and white rot fungi by 44% and 69% respectively. And in another study, the veneer from the outer and inner layer of the oil palm trunk are mixed, and they mix using the previous two methods. They mix it using the mixed outer and inner layer to form a plywood, and the plywood made from outer oil palm stand have better mechanical properties. And also the plywood made from the resins treatment also has a better surface characteristic, and density of the veneer was improved significantly. And another study is also the veneer pre-treatment, soaking for 20 seconds using a different molecular weight, and it found that the veneer treated with low molecular weight PF resin had significantly higher volume percent gain and weight percent gain. And impregnation using a different resin solid content of 15, 23, 32, and 40s. And we found that the high mechanical properties in plywood made with oil palm veneer treated using higher resin content, resin solid content, and the formaldehyde emission increased along with the increasing solid content. Also, impregnation, they're using impregnation and the different hot pressing time. And found that the mechanical strength improved along with the increasing hot pressing time. And also the impregnation using a different pressure of 20 bar, 30 bar, and different stages. And they found that the two-stage pressure result in better mechanical properties of the produced plywood. So this is the some of the works that have been done on the resin treatment on oil palm trunk veneer to improve the properties of the plywood. This is mostly for the lab scale. And lately, we have conducted an upscale resin treatment process of oil palm trunk veneer. So this is the vacuum pressure impregnation cylinder in a local factory in Malaysia. And then this is the oil palm veneer treatments. So we loaded the dry oil palm veneer in the cylinder, and then using the forklift, and then after treatment, you treat using a phenol formaldehyde resin, and then after treatment, you can see that this is the veneer after treatment with very many bundles of veneers after treated with phenol formaldehyde resin. And this is the after treatment. So we will drying of the treated oil palm veneer. So we will pass the veneer through the veneer dryers to slightly reduce the moisture content of the veneer to around 20%. So up to around 20%. So when during the hot pressing, blistering will not occur. So after pre-drying, so this is the assembly of the treated oil palm veneer prior to hot pressing, and then we feed the assembled veneer to the hot press. So this is the upscaling treatment that have been conducted in local manufacturer in Malaysia. So this is some of the results we would like to share. So we can see that the resin treated plywood made from the previous process has a very excellent fungus resistance. So we can see that the fungus after 8 weeks of exposure to white rot fungi, we can see the surface of the resin treated plywood is totally completely free of the white rot fungi. But the control plywood, commercial plywood, rubber wood plywood is already fully covered with the white rot fungi. And this is the resin treated plywood also show a very quite good termite resistant. As we see, there is no visible damage from the termites attack, except from some cracking here, maybe due to the moisture in the jar. And that this is the controlled rubber wood. Rubber wood, we can see that there is some damage by the minor damage by the termites. So when you compare with the resin treated plywood, plywood display a quite good termite resistant, and also very good weather resistant. So the plywood has been subjected to 3-month outdoor exposure, and we can see here the weather resin treated plywood, and compared to the commercial plywood, we can see the commercial plywood already has a discoloration, and also it has been molded. But the resin treated plywood is still stay intact, and the surface is still look very clear, very nice. And compare with the unweather resin treated and the weather resin treated plywood, actually the resin treated plywood has a little bit darker in color, maybe due to it is in a wet condition. So we can conclude that the resin treated plywood has a very good weather resistance. Okay, so here come the conclusion. So the waste biomass from oil palm has been extensively studied and found to have a huge potential to be converted into value-added products and bioenergy. So many comprehensive review and research reports have been published to assess this potential, and small to pilot scale study has also been established to show the feasibility of the utilization of these biomasses. However, the issue here is how many governments or private initiatives are available to develop a secondary products from this waste biomass in the country. Also, are the plantation developers and smallholder willing to leave out the biomass from the plantation to this waste processing plant? So one major factor which plantation developer would consider before agreeing to move out the biomasses, in this case, would be the cost. The cost to move the transport, the cost to move and transport this oil palm trunk consists of operational and transportation costs. So operational costs would include the cost to collect and pull the oil palm trunk from the entire plantation to a collection hubs within the plantation. So the transportation costs will include the cost to ferry this oil palm trunk to the processing center, which is influenced by the distance between the plantation and the processing center. So ideally, this processing center are to be located close to the plantation to reduce the logistic cost. And the second, apart from the cost concern, the second concern would be the nutrient imbalance in the soil, which can be triggered when all the biomass are removed from the plantation. So actually the planter, the smallholder, they are afraid that after remove all the waste from the field, and their soil will become infertile. So this is another concern that we have to take into consideration if we want to apply the oil palm biomass sustainability. So a proper cost analysis must be established to critically review the impact, losses, and profit that are incurred when the oil palm trunk are removed or retained in the plantation. So that's all from me. Thank you very much.
Thank you very much, Dr. Lee Seng Hua, for your clear and interesting presentations. Let us give applause first and appreciation. Now I will open for the questions and answer sessions, Mr. Dr. Lee Seng Hua. We have 2 questions here. Firstly, from Aulia Fadila, which is raised hand, and the secondly, from the chat column from Jacinda Aurel and from Asri Widianti. First one, let me open question for Aulia Fadila. Aulia Fadila, the time is yours. please.
Thank you, Ms. Puspita. Good morning, Dr. Seng Hua. My name is Aguilar from Agro-Industrial Technology of Padjadjaran University. I want to ask about this presentation you have presented. Based on the opportunity, one of the application of oil palm trunk is for fluorine. What are the difference in quality or characteristic between lumber-based product versus vinyl-based product for fluorine production or application? Thank you, Doctor.
Okay. Thank you very much. I'm sorry, can you repeat the first question? Hello? Can you?
Pardon, Doctor?
Oh, so can you repeat the first question?
Oh, right. Okay. Based on the opportunity, one of the application of oil palm trunk is for fluorine. What are the difference between lumber-based product versus vinyl-based product for fluorine application?
Okay, so thank you very much for your question. And I think in comparison between the lumber base and the can you hear me? Yeah. Between the lumber base and the veneer base for flooring application, based on my own experience, I would suggest the veneer base because when the veneer when you produce the oil palm trunk veneer, it will come a peeling process. So the peeling process, because we know that the oil palm has a very high density variant. From the outer has the very high density, and the inner has a very low density. So when we apply the peeling process, we can ensure that the density gradient is minimized. If you want to convert it to a lumber, you need to the lumber, because the lumber you have a very high density variant between the lumbers. So from the outer layer and inner layers, so you will have to apply many treatment like the densification, like resin treatment. But for the veneer, the peeling, you can ensure that the veneer produced has a very less density variance. And for the flooring products, actually for the engineered flooring products, we needs a very low, very thin veneer that laminate on the solid wood. So for my experience, veneer is the best. Veneer base is the best option for the flooring. Yes.
Okay, thank you, Dr. Seng Hua Loy.
Welcome.
Thank you.
Thank you, Doctor, for your brief explanations. And now we move to the next questions from the Jacinda Aurel. Hello, Jacinda Aurel. Do you want to ask directly to Dr. Lee Seng Hua, or I read your questions? Jacinda? Okay, Jacinda asked me to read the question for you, Doctor. Hello, Dr. Lee Seng Hua. My name is Jacinda from Padjadjaran University. I want to ask you, based on your experiment, how much time required for air drying and forced air drying method for oil palm trunk?
Okay. Okay, thank you very much, Jacinta. Thank you for your question. And based on my experience, if you're using a air drying method, it's required around 30 days. 30.
1 month.
1 month, yes, around 1 month, to reduce the moisture of the oil palm wood to 60 degrees Celsius. 60%. That is, we just talk about 60%. So we need 1 month to reduce to 60%. If we require a lower moisture, such as 10% or 20%, we require more days. I would expect 2 to 3 months. And for the forced air drying, just now I shared that forced air drying, we will the time required for the oil palm wood to reach 60% moisture content is around 11 to 16 days, so half a month. So this is the difference between the forced air drying and the air drying.
Okay, it's quite long times needed
Yeah.
to drying.
Yes.
With air force or air conditioners. Okay, we move to the next questions, sir, from Mrs. Asri Widyasanti. To Dr. Seng Hua, Ph.D., I have two questions for you. Firstly, I am interested in the drying process of oil palm wood. And then could you please more explain about it? Do you use any drying machinery? Since it requires very long drying period and it possesses a very high moisture contents, which one is the best drying practice? Air drying, forced air, superfast, or modified superfast? And the second questions for Ms. Asri Widyasanti is the recent technology to enhance quality of oil palm wood extracted from oil palm stem, which has characteristic of low strength, low durability, poor machining characteristic, and several drying effect. I am thanks in advance from Ms. Asri Widyasanti.
Thank you very much, Vidyasanti. Thank you for your question. So I will discuss about the first question first. Explain on the drying of the palm. So for the air drying, it's just a normal air drying. So for the forced air drying, we will use the fan. The fan will just provide the airflow. So it's a very simple drying method. So we use a fan, industrial fan here, and then we provide the airflow to the stack of the oil palm lumber here. So and for the super fast drying method, so this one is when we have oil palm lumber, we will make the holes on the oil palm lumbers. So in order to facilitate the drying process. So after the holing process, this is holing. Holing is just a very simple equipment. And then for the direct contact drying, it's just using a hot press. We just at 180 degrees Celsius, and that will compress a little, use to reach 20% compression ratio. And then, but the most important thing is that you have to separate the outer layer and the inner layer. So for the outer layer, you use one cycle of the direct contact drying, and then for the inner, you have to use two cycles because inner has a more higher moisture content. And after the direct contact drying, the oil palm lumber will be put in the oven, just an oven for high temperature drying for 100 degrees Celsius and for 3 hours. So that's it. That is the whole process. But this process is unfavorable because we need to use the holing process on the oil palm lumber. So it means that when we doing the lamination process, we can see that there is a hole on the surface of the oil palm lumber. So therefore, I would suggest to use this one, the modified super fast drying. So using this, we combine the air force drying using the industrial fan to reduce the oil palm lumber to a certain level, certain moisture content, and then we use the super fast drying method we mentioned before, using the direct contact drying, and then using hot press, and then put it in the oven for high temperature drying, and then we will in using this method we will produce a clear surface of super fast dry oil palm lumber. So this is good for us because we can use it directly as during the lamination process because the surface is without hole, is clear, so it looks very clean. So if for me, the suggestion is the best so far is the modified superfast drying with a combination of forced air drying and the superfast drying method. So for your second question, I'm sorry, is the recent technology to enhance the quality of oil palm wood extract? Okay, so for this one, I think yes, there's certainly they have many improvement study to research to improve the properties of the oil palm wood extract from the oil palm stem. One of the like I discussed before, the most popular method will be using the phenolic resin treatment. But apart from that, because you can use a lot of different methods, such as the heat densification, because the oil palm is very low in density, and when you densify it, it will become a very good products with very good properties, very good performance. But mostly, I think it's the impregnation using phenolic resin, or using other thermosetting resin, such as melamine formaldehyde, urea formaldehyde. That would be a possible way to improve the performance of the oil palm wood. So that is my.
Okay, thank you, Doctor. It's very clear and brief explanations. Actually, yeah, thank you very much for the explanation from Miss Asli Widyasanti. Okay, Doctor. Actually, I have a questions for you also about the properties of the product. You say that the moisture content reduced to 60 until 70% after treatment, which is we have compregnations and impregnations. But how about the density and hygroscopic properties of the lumber-based products after the treatment?
Oh, okay.
Thank you.
Before the treatment, the oil palm we use has around 200 to 300 kilogram per meter cubes. And after the treatment, some of the oil palm wood can reach to 900 to 1,000 kilogram per meter cube. It's very solid, very rigid, and we can say it is the hygroscopicity has been reduced greatly, because we have tried after the complex oil palm wood we have produced, we soak it in water for two weeks. And the lumber, the thickness of the lumber did not change. It just changed very little, below 1%. So it's very dimensionally stable. So we can say that the hygroscopicity of the lumber after the resin treatment has been reduced significantly, very greatly. Yeah.
Okay, so the moisture content and also hygroscopicity was reduced after treatment, yeah, Doctor?
Yes, yes.
Okay, but can we process the moisture content that reduced after treatment into the steam, for example? Moisture content, for example, before treatment is 200, after treatment 60%. And then how about the moisture content loss from the palm trunk, oil palm trunk? Can we process it into the energy such as steam, for example, or other chemical substance, like for hygroscopicity, like sodium hydroxide, which has hygroscopicity properties?
I'm sorry, you mean the moisture during the process, the moisture loss, can we use it as to generate the energy?
Yes, maybe.
Maybe.
It's
Yeah,
just my hypothesis.
I think it could be very feasible, because the moisture loss seems very much there. So I think this is a good idea. Maybe we can try to explore. I'm also not sure, but I think it is feasible.
It's visible, yeah. Okay,
yeah.
Doctor.
Because the moisture loss is very high in there, so
we can
utilize it. Yes.
to be more
Yeah.
valuable product.
This is really a good idea, Dr. Puspita.
Okay, thank you, doctor. And then we move to the next questions from Miss Drupadi Ciptaning Tias about phenolic resin treatment on the oil palm vinyl. Is it make a stronger and more stable polywood, and how optimizations of resin treatment process occur in the oil palm vinyl, doctor?
Hi, I'm sorry. Let me. How the
From
optimization of resin treatment process occur?
Yeah.
Okay, so when we treat the oil palm vinyl, actually, where oil palm vinyl is very porous, and then when we treat it, what we want to see the first is the weight percent gain, and the polymer retention. So if it achieves high enough weight percent gain and polymer retention, weight percent gain, I would say that if you achieve 20 to 30% weight percent gain, it will be sufficient. But after that, you have to when during the process of plywood using the treated veneer, you have to optimize the pre-curing temperature. The pre-curing temperature, like for like we in my study, is for 70 degrees for 40 minutes to 1 hour to procure the resin in the veneer, and then you will subject to hot pressing. The hot pressing is quite tricky sometimes. If the veneer is too wet, it will be it cannot be bond together. So this is the variable that you have to consider. So first is the weight percent gain and the polymer retention. And then after that, you have to determine the pre-curing temperature in the oven. Mostly it's 70 degrees Celsius for 40 minutes or 1 hour. So you make sure that the resin in the veneer is semi-cured. So when you take up the veneer sheet, the resin is already in the gel form. In the gel form, it's not dripping. So after that, you can subject it to hot pressing, and the hot pressing you can play with the temperature and pressing time. That's it, the optimization process.
Okay. Okay, so the resin form is in the gel form, yeah, not drop as a liquid.
It's actually, yeah, when we touch it, it's feel like a gel form. It's a gel, and you touch it, I mean the resin, it will not stick on your finger.
Okay. It's very clear. Thank you from Drupadi from Universitas Padjadjaran, doctor. And then we move to the next question from Val Prihad about the moisture content of inner part of oil palm trunk much higher than outer part. The question is, what is the best drying method for reverse can saving? The question from Val Pritchard.
Okay. So the best thing about the reverse can solving is that we can maximize the oil palm, the outer layer of oil palm, and then but we also can take the inner part. So in the process, the modified super fast drying method. We use the reverse can solving, and then we segregate into a different outer and inner layer. So the best thing, the uniqueness of this modified super fast drying is that we can dry both outer and inner part of oil palm. So it means that but using a different cycle. The outer layer we just use one cycle of direct contact drying, but the inner we use a direct contact 2 cycles. So this is the best drying method for the reverse cancelling is the modified super fast drying. Super fast drying is also okay, but like I said before, it will cause the holing in the surface of the oil palm wood, so it is not favorable sometimes. So for me, I think the modified one is the best. Thank you.
Okay, thank you for the explanations, Dr. Seng Hua. We move to the next question from Arif, Universitas Padjadjaran. He also curious about the lumber-based product and veneer-based product for flooring applications. Could you please explain more about it,
Oh,
Doctor?
okay. Okay. The different quality of credits. Okay. So actually, I think the main difference for the lumber-based products and the veneer-based product for flooring application is, for me, is the veneer-based. You can use it because for the engineered wood, engineered flooring, you will have a very thin layer on the surface of the flooring. So for the veneer, you can use it. You can after peeling with a very good density, and then you can do some treatment, and then you can apply it on as a surface of the engineered floor. But for the lumber, the lumber is possible too. But the lumber, we can use the densification method, and use it at the back core of the floor. So we're using another layer of veneer to cover the back core. So for me, I think it can be used as a different application in flooring. The veneer can be used as the surface layer of the engineered floor, but the lumber, after densification, after resin treatment, you can use as the back core of the engineered wood, engineered flooring. Yeah.
Thank you very much, Dr. Seng Hua. We still have 10 minutes for discussion sessions for participants. If you have any questions for Dr. Seng Hua, please don't be hesitate to raise your hand in the raise hand feature, or write down your questions in the chat box feature in this Zoom meeting. Okay, we wait maybe 1 or 2 more questions for the from the participant, Doctor. And
Okay.
while we waiting, I have one question for you about the resin utilizations. Is there any other resin utilizations based on your experiment which suitable for this treatment for oil palm trunk, Doctor?
Oh yes, actually there's a plenty of chemicals that we can use to treat treat this oil palm wood. So like I said before, the phenolic resin is one of the most popular used. And actually in the thermosetting family, such as the urea formaldehyde resin, the melamine formaldehyde resin, we can also use it to impact the oil palm wood. But this resin is mainly for the bucking effect. So it means that the chemical reaction won't occur between the hydroxyl group of the oil palm with the phenolic resin. So actually, other than that, you can use some chemical that can create esterification of the sun-etched citric acid. You can use the citric acid. Because the citric acid, you have the ester group that can react with the hydroxyl group of the oil palm wood. So would be a very good chemicals used to treat the oil palm wood. And citric acid is green, and except for that, we can use purple alcohol for impregnation. Yeah, purple alcohol is also a green option, green alternative. So there's plenty of chemicals that can be used to improve the properties of the oil palm wood, depending on what mechanism do you want to achieve. You want to achieve the bucking effect, or you want to achieve the esterification, the chemical reaction between the impregnant and the oil palm wood. So there's plenty. Yes.
Okay, Doctor. So many types of resin that can be utilized for this treatment, yeah,
Yes.
Doctor. And we move to the last questions, maybe from Farah Nuranjani. Miss Farah, say thanks to you for your presentations. Dr. Seng Hua, I would like to ask, what are the factors affecting the quality of oil palm trunk? Thank you.
Okay. So actually, as a wood sign, so from my point of view, I would say that the factor that affecting the quality of oil palm trunk, apart from the silvicultures, more that all is I am not very familiar with. But for the wood itself, for the oil palm wood itself, I would say is the density. The density, like the porosity. Because the porosity, because when we can see the whole trunk, the whole oil palm trunk, it has a very different density when the density decrease from the outer into the inner. So I would say this is the one of the main factors that affect the quality of the oil palm trunk. So the oil palm trunk with high density will be high in strength, and then the oil palm trunk with a low density will be very poor in strength. And also the moisture content. So the moisture content variation, we know that the oil palm has very high moisture variation throughout the trunk. And then when the oil palm trunk has very high moisture, like the inner part, so when you dry it, so it will become, it will have a very much drying defect. So because you have very high moisture in the wood, so when they string a lot, and then it will affect the mechanical properties of the oil palm. But the outer will be better. So I think this is the moisture and the density are the main factor that affect the qualities of the oil palm trunk.
Thank you very much, Doctor. Your explanations to answer the question from our participant. Unfortunately, the time of our session is up. Finally, I can summarize that the oil palm trunk as waste biomass has a great potential to be converted into value-added product. The quality of oil palm trunk can be enhanced to the lumber-based product via impregnation or compregnation and veneer-based product, which has excellent fungi resistance and also good termite resistance. But one of our challenge here is how to ensure the long-term sustainability ability of this crop for wood-based industry. Mr. Dr. Seng Hua, we would like to give a certificate as our appreciation for you, for your contributions for our agenda today. We really appreciate it. Thank you for your support, contributions, and we hope stay tuned in this mobility program. Okay, ladies and gentlemen, this is end of our sessions. I am Puspita. Stay safe, happy, and healthy. See you again. I pass the next session to the MC. Amel and Naufal, please.
Thank you very much.
Amel and Naufal. Please wait a moment first, Doctor. Thank you. Yeah, Amel and Naufal, please.
We would like to.
Sorry, Amel and Naufal. Okay.
Okay. Thank you very much, Dr. Seng Hua, for giving such an informative and comprehensive presentation. And next, we would like to present Dr. Seng Hua with a certificate of appreciation for doing a great job today.
Thank you very much.
Thank you very much, Dr.
Thank
Seng
you.
Hua. Thank you very much.
And thank you very much, Dr. Puspita, for being our wonderful moderator in this session. And before we end this session, we would like to present Dr. Puspita with a certificate of appreciation for doing a great job today.
Thank you very much, Amel and Naval.
Okay, we would like to take a photo right now on my count from 1, 2, 3.
Okay, thank you very much, Dr. Puspita and Dr. Seng Hua. So, ladies and gentlemen, without any further ado, we will now begin our next session, and our next agenda will be talking about circular economy in the development of agro-waste-based biomaterials.
This session will be led by a moderator, and our moderator for this session is Dr. Handarto.
Allow me to read his short bio. Dr. Handarto is a lecturer and researcher of Department of Agricultural Engineering and Biosystem, Faculty of Agro-Industrial Teknologi, Padjadjaran University. Also, Mr. Handarto received his Ph.D. in Diversity and Fractal Sciences from Chiba University, Japan. And Dr. Handarto has many research topics such as greenhouse technology, natural ventilation analysis for agricultural buildings, structural and functional analysis of greenhouse, and energy and water vapor mass balance analysis on naturally ventilated greenhouse with fog cooling system.
Okay, to Dr. Handarto, you may proceed.
Thank you, MC. Good morning, distinguished participants. I'm Handarto. It gives me a pleasure to be the moderator for this session. And before the presentation begins, let me tell you how this session will run. Firstly, the speaker will present the material for about 45 minutes. After that, we will have a question and answer session for approximately 10 minutes. And finally, the session will be ended by conclusion. Ladies and gentlemen, first I would like to read a brief introduction to our speaker for this session. Prof. Myrtha Karina was born in April 1st, 1958. She obtained her doctorate program from Kyoto University, Japan in 1993 in the field of wood science and technology under supervision of the late Professor Takayoshi Higuchi. Her specialization is in natural polymer-based composites. Bacterial cellulose becomes her research topic interest in the past few years. Prof. Myrtha has published more than 100 original research articles, 2 books, and 11 patents with her research team. She was also awarded with multiple both national and international research grants since March 2022. She is affiliated with the Research Center for Biomass and Bioproduct at the National Research and Innovation Agency, or BRINS. Ladies and gentlemen, as we know that biomaterials, being environmentally friendly alternative to synthetic materials, are gaining increasing demand for various applications. Hence, biomaterials development should be integrated with the circular economy models to ensure a sustainable production that is simultaneously harmless toward the environment. In this session, we will get a closer look into difference between circular economy and linear economy, bacterial cellulose, including its resource, production, purification, and application, and also a concept of the circular economy in agro-industrial residue. All participants, without further ado, now allow me to welcome Prof. Myrtha Karina to deliver presentation entitled circular economy in the development of agro-waste-based biomaterials. Prof. Myrtha, time is yours.
Thank you so much for Dr. Handar for the introduction. So let me share my screen firstly. Okay. Oh. Okay, which one? Wait a minute. I think I have trouble with this. Wait a minute. Apologize, Dr. Handar. Wait a minute for sharing.
Can we help you? Because, yeah, something trouble occur in this connection. Okay. Yeah. Prof. Myrtha, operator will show your presentation slide.
Dr. Handarto, excuse me, there must be something wrong with my share screen on my laptop. So, but I have sent already my files to the organizing committee. So please, organizing committee, share my files.
Yes.
Okay.
Okay.
Okay, so I apologize, everybody. Okay, good morning, everyone. Hope you are all doing well. Firstly, let me address my appreciation to the organizing committee who gave me a good opportunity to deliver my speech today here in Second Virtual Mobility Program. My name is Myrtha Karina from Research Center for Biomass and Bioproduct National Research and Innovation Agency, BRAIN. My talk today will on the circular economy and the development of agro-industrial based biomaterials. Next, please. To begin, I would like to quote from the United Nations Environment Assembly in 2019 that circular economy is economic models that involves all products and materials that are designed to be reused, remanufactured, recycled, or recovered and maintained in economic activity as long as possible. This model is designed to replace the linear economic model as defined as, next, an economic system based on collecting raw materials, using them to create consumer goods, and disposing of resulting waste products. In our current economy, in conventional current economy, we take materials from the earth and then make products from them and distribute and consume it, and eventually throw them away as waste. And this process is called as the linear economy. This is difference with a circular economy. In this circular economy, by contrast, we stop producing waste and we recycle it or reuse it, and finally goes to the recycling sector. Next. So why the circular economy important? Because the circular economy can provide economic, social, and environment benefits. In Indonesia, if Indonesia continues to consistently apply for circular economy practices, carbon dioxide reduction can be estimated to up to 15% in 2030, because this it can reduce the amount of greenhouse gases released through the reducing the amount of waste which is deposed to landfills, for example, reducing the amount of food waste due to the increase of consumer awareness. And also because the use of alternative raw materials that are more energy efficient, for example, the greater volume of wood utilization and more wood-based construction compared to concrete. And then we also it can be also extending the useful life of resources. For example, more clothes that can be reused if rent or exchanged by a second if necessary, or recycling system is implemented. And last but not least, of course, the reduction of new resources. All of these things can reduce the carbon dioxide up to 15% in 2030. Next, the implementation of circular economic principles represented by 36 initiatives in Indonesia shows a positive impact on the environment, economy, and social, as described here, such as operational cost saving, and then operational cost saving, and then possible job creation, emission reduction, and then also huge amount of waste reduction, as well as energy saving. This data actually was presented by Biomass report entitled The Future Circular this year. Next. In 2020, 5 sectors have been identified that have the largest circular economy potential in Indonesia, namely food beverage, and then construction, electronics, textile, and plastic packaging, all of which still significantly related with the petroleum-based plastic. And all of this circular economy potential in Indonesia still has related with petroleum-based plastic. So let me introduce or explain briefly about the petroleum resources situation in Indonesia. Next, please. Okay. So this is the current or the description about the Indonesia oil reserves. This year, the Indonesia reserve of petroleum oil is approximately available for about 3.6 million barrels. And if there's no new oil resources are found, as well as no new refineries establishment, then it is predicted that Indonesia's oil reserve will last in 2030. On the other hand, nowadays petrochemical industries are the source of more than 99% of the plastic raw materials. Additionally, the petroleum-based plastic is non-degradable, more specifically non-biodegradable. So let me explain briefly about non-biodegradable plastic goods that we found in our daily life. Next, please. Okay, this is the plastic shopping bag. the most frequent plastic use found in our daily activities. It is very light, it is very handle, practical in use, and very cheap, so we can find it everywhere. But when its lifetime is ended, the disposal will cause an environment problem since the low density of polyethylene is hardly degraded. It just changed physically around 502,000 years. So you can imagine how it's very long to degrade, but not totally degrade, but it's just physically changed. And this is the food packaging based polystyrene that usually commonly well known as styrofoam. The polystyrene, styrofoam based food packaging is more or less similar with these shopping bags that but it's shorter in physical changes, almost 50 or 60 years to change. And how about this PVC pipe and this plastic rope? This polyphenol chloride pipe and also a polypropylene based plastic rope. This is the questionable whether it is could be degradable, it is degradable or not. So this is all of these things. It's the problem for our environment when its lifetime is ended. So the degradability when this products is over of its lifetime. So it is a really a big problem, especially for the environmentally problem. So you can imagine that other than this four type of plastic, there are a lot of many other types of plastic are still produced due to the increase of our plastic demand. And when the next please. So the accumulation of plastic waste required. The accumulation of plastic waste is required to for proper handling to solve the environment problem. Several techniques actually has been done to solve the problem. Recycling, for example, is carried out through the washing, the crushing, or the reforming of the material itself. These steps is really necessary for recycling. But the question is it economical or energy efficient? Oh, sorry. The question is whether this recycling process is economical or energy efficient. There are still some question due to the recycling process. And Paddy reported that only 25% is recyclable. Another technique is incineration. The incineration also has been carried out to solve this problem, but the proper incineration technology, incineration technology with the less control during the implementation will cause toxic for human and environment. Because the emission during the less control of this incineration treatment. And last but next, please. And for additional information, in fact, recycling process cannot solve to the entire plastic waste problem because plastic can be recycled only maximum 9 times before it is no longer recyclable. So last but not least, that the plastic waste is discarded into the landfills. But the improper plastic waste could become a severe environment problem. Next, please. Okay, due to the poor or improper management of the plastic waste can be finally found in the river and goes to the ocean and goes to the ocean. So this is the data in the right side of this slide that the plastic bags is the most plastic garbage that dominates in the ocean garbage. So it is really normal because most of the plastic production is addressed for the plastic bags. Next, please. Okay. Due to the poor management of this plastic, as I mentioned before, that plastic waste are also found in rivers. It was reported that almost 80% of plastic waste is distributed by more than 100,000 rivers globally, which slowly goes to the ocean and become marine pollutant, and gradually would become a global oceanic problem. Next, please. Bulky plastic, often as a macroplastic waste derived from the plastic waste, have been found in the ocean, and its accumulation is significantly increased. As a result, marine animals were suffered and killed by plastic entanglement. So in the ocean, plastic gradually degrades into microplastic, which its accumulation is very dangerous since it is easily swallowed by fish or any other ocean creatures, which is commonly consumed by human beings. One of the study showed that the change in the microplastic abundance over time increased systematically, which is not only local, but regional and even maybe global in scale of the macroplastic found in ocean. As many of the world megacities located near the coastlines, adjacent coastal waters are often elevated in marine plastic abundance, which in turn impact local fisheries and seafood safety. So when we discarded our plastic waste in the landfill without any proper management, so this kind of activities, this kind of fact could be found in our environment. Based on this condition, that's why agro-waste, the alternative source of the petroleum-based plastic replacement, is consequently based on our previous description. Consequently, an alternative sustainable biodegradable-based plastic specifically originated from organic resources are important as alternative plastic resources. Next. The alternative source for petroleum-based plastic replacement is addressed to cellulose and lignin. This is the most natural polymers, which is found very abundantly in our planet. This could be considered as the most promising for the plastic alternative replacement. Agro-industrial residue, or sometimes we call it as agro-waste, has been defined as agro-waste from food and agriculture industry, and also defined as any lignocellulosic residue produced by agri-food industry in their daily operation. Next, please. Based on the definition of ROSA, there are 4 groups of agro-waste actually. This is very simple. Typically, oil agro-industrial residues, food agro-industrial residues, wood agro, and animal agro-industry. But in this today's discussions, I just focus on the food agro-industrial residues and wood agro-industrial. Next, please. Okay. Due to the interest of this topic, I mean the agro-industrial residues topics, the research field on this related topic is increasing and proved by the scientific publication, which is this is the number of the publication on agro-residues, which is indexed by Scopus. So we can see here from 2000 and 2020, there are a lot of scientific publication, either in review article or research article. This means that so many researchers are interested to carry out the research activities on agro-industrial residues. Actually, the data on 2022 is already available. Next, please. Okay, as I mentioned before, that cellulose and the lignin contains in agro-industrial residue could be used as an alternative resources for plastic production, but they are also as a promising material for pharmaceuticals, for biofuels, for food ingredients, building reinforcement, nanomaterials, and adsorbent, and of course many other possible application could be produced from these resources. Please. Okay. Excluding from what mentioned in the previous slide, that agro-industrial residues have been used for example, for fiberglass replacement in composite, for example, in building material, in automotive. So on the other hand, fiberglass is quite dangerous when the producers of in the manufacture contact directly. So it is not good for human being or the workers in the related industry. So many agriculture industrial residue have been proved as the fiberglass replacement in this composite. Next, please. Okay, as I already in agro-industrial residues, cellulose and lignin are found as the most important component. This data shows that since contains of cellulose in lignin, but some of them found in high amount of agro-industrial residues, especially which is listed here, because they are contained of cellulose and lignin. It can we can say that these resources can be as a potential or alternative resources for plastic application. This data actually have been collected from various resources, but compiled by Matteo last year. So based on this data, as described here, that for example, coconut husk fiber, raw banana fiber, and then sorghum bagasse, soy hulls, and sugarcane bagasse, which is contained of cellulose and lignin. So they can be a potential resources to be developed for plastic resources. Next, please. Okay, the plant cellulose and lignin, which is found in agricultural residues, especially cellulose in plant resources, is chemically linked very hard with lignin and hemicellulose, but especially lignin and cellulose linkage. So this chemically linkage is quite actually difficult or very hard to separate or to isolate them individually. Therefore, their isolation or their production individually should be carried out through several pre-treatment. This is very important because sometimes this agro-industrial residue, agro-waste, is not directly used for new material, but it will be, but it is used individually. For example, cellulose itself or lignin itself. Next, please. Okay, there are several pre-treatments are available to obtain cellulose or lignin as described here, such as chemical treatment, and then physical treatment, biological treatment, and enzymatic treatment, which generally all these treatment requires harsh chemicals that sometimes not environmentally friendly. But in steam explosion or steam treatment, especially for the hard material, I mean for the hard material derived from agro-industrial residue, this is the steam explosion just required a very minimum or chemical subjection. Next, please. Okay, so this is the steam explosion or steam treatment of the agro-industrial residues, where the minimum of chemicals is required. So at least let's say that very minimum of chemical is required during the steam explosion treatment. I can say that mostly water is required for lignin and cellulose isolation during the steam explosion. This is the example of which the steam explosion treatment was carried out. Of course, the condition or the parameters could be varied or could be adjusted. But I can say that the higher the pressure and the higher the temperature, so the easier to cleave or to separate the chemical linkage between cellulose and lignin. Next, please. Okay, when cellulose and nanocellulose has been successfully obtained, either by any pre-treatment, either by chemically, by biologically, or something else, so the various possible application is widely open. So the left side is the general view of the application of cellulose in textiles since a long time ago, for electronics, for industrial and biomedicals. And excluding in this application is traditional wood application in construction or making furniture and appliance. Of course, many other possible application is available for this cellulose application. With the rapid development of modern nanotechnology, the generation of nanocellulose provides a new direction for high-value utilization, as described here. As we can see here, the application between cellulose and nanocellulose is quite the same. I mean, for example, in textile. So cellulose application is found in textile, as also similar with the nanocellulose application, and also for paper production or food industry. But the difference is lies on the properties of the nanocellulose itself, because nanocellulose because cellulose is now changed or developed into the nanoscale dimension. So the properties and the performance of the cellulose, this nanocellulose, will be much higher than the cellulose itself. So the differences, once again, I said that the differences lies on the properties and the performance of the resulted products. Okay. Besides derived from vascular plant, cellulose could be produced from algae, from fungi and bacteria. And among these different types of microorganisms I just mentioned, the most efficient producers of cellulose are acetic acid bacteria, which is commonly well known as bacterial cellulose. And so far, it has been applied as a model for microorganisms for basic and applied cellulose studies. As I mentioned before, that in vascular plants, cellulose is chemically linked with lignin. Therefore, to produce pure cellulose, chemically treatment, which I mentioned, should be carried out. On the other hand, bacterial cellulose produced by this bacterial activity is classified as pure cellulose. Therefore, no further chemical purification is required. So by the activities of this bacteria, only cellulose and water produced from their activities. Next. So bacterial cellulose is produced commonly by the non-pathogen, either gram-positive or negative, and it can be produced in suitable medium containing carbon and nitrogen by the static or agitation technique. By the agitation technique, the spherical-like gel where by the agitation technique, the spherical-like gel will be produced. But on the other hand, by a static method or static technique, the thick pellicle produced in the top side of the container. The cellulose produced when after the incubation of the bacteria, the cellulose produced should be, even though it is only contained of cellulose, pure cellulose and water, but sometimes we need to purify this bacterial cellulose because probably it still remain of bacteria itself or the remain nutrient that we have to purify. Usually the purification is carried out by boiling in the dilute sodium hydroxide to remove or to finish the bacterial bacteria remaining in the medium. But recently, we also it has been proved that not only using the sodium hydroxide, we can minimize and we can remove the sodium hydroxide just using boiling water. So by this by this treatment, can be proved. It already proved that the cellulose resulted is free from the bacteria or the remaining nutrient. Next, please. This can be seen here. This is the scanning electron microscope images of the 3 samples of bacterial cellulose, which is first one in the left side is the bacteria cellulose remain a bacterial cellulose without purification. So the bacteria remains in the gel. The middle the middle part is the bacterial cellulose purified by boiling in dilute sodium hydroxide. So from this same images, there's no bacteria left on the gel. And the right side is the bacterial cellulose produced by using the agri-industrial residues, and the purification was done just in boiling water. But even though there's no sodium hydroxide is used in this purification, we can see that there's no bacteria remains or there's no other impurities in this gel. But sometimes sodium hydroxide is also required during the purification because the study proved that the addition of sodium hydroxide in a very low concentration, it was reported it could be increase the mechanical properties of the resulted gel. Next, please. Okay. Interestingly, that bacterial cellulose, well known as nata de coco, is usually produced on purpose for a dessert. But actually, several studies reported that the cellulose gel is formed to protect the bacteria itself from the unfavorable conditions such as UV radiation, harsh chemicals, or the excess way to have the oxygen. Because the acidic bacteria, which is actively producing cellulose, is categorized as the acidic bacteria. Next, please. Okay. Bacterial cellulose is commonly well known as nata de coco if bacterial cellulose is cultivated, if bacteria is cultivated in coconut water. But if it is grown in pineapple extract, pineapple juice, or pineapple peel, then it is called as nata de pina. So as with nata de soya, if it is prepared from tofu liquid water or tofu solid water, and it is called as the nata de soya. So similar with nata cassava, nata de cassava, because if the bacteria is cultivated in the cassava, liquid or solid waste. So if you can see here, not only these 4 agro-industrial residues, but there are so many possibilities to produce bacterial cellulose from other various underutilized agro-industrial waste. Next, please. So this slide shows the possibility of other agro-industrial residue for bacterial cellulose production, which is developed further for new materials. There have been various efforts to use this agro-industrial to try to use as the medium growth for bacteria. So we cannot imagine before that from nata de coco, let's say the basic bacterial cellulose found in the first layer, which is commonly known as dessert, we can produce as a novel material. And as it described here, various agricultural residues such as apple, from pineapple, from forest fruits, and many other from industrial, for food and wood industrial residue, we can produce bacterial cellulose, which is further developed for new materials, such as here you can see for antioxidant films for food packaging, composite for suspension stabilizer, membranes for water purification, for electronic device, chip memory, nanocomposite, wound dressing, and for pharmaceutical industries. The possible of this could be happen, of course, because of the technology development and awareness of the environment to solve the waste problem, especially due to the waste plastic cost, and in line with improving the added value of the agro-waste itself. Next, please. Okay. As I mentioned previously, that bacterial cellulose could be produced in the suitable medium containing carbon and or nitrogen. And then how could agro-industrial plays a role in the bacterial cellulose production? This slide shows the carbon and nitrogen content in several agro-industrial residues, and depends on the type of the resources, depend on the type of plant in the agro-industrial residues, the concentration of carbon and nitrogen is varied. This content, of course, will affect the bacterial properties such as mechanical strength and crystallinity, which further affect the properties performance. The higher the content of the carbon and nitrogen, of course, the higher it has been proved that the higher mechanical strength of bacterial cellulose will be produced. Next slide, next slide, please. Agro-industrial carbon and nitrogen content also could be represented by the carbohydrate and protein content. Here, the slide shows some agro-industrial residue with carbohydrate and protein content. Depends on the type of plant. The concentration of carbohydrate and nitrogen is varied. These two factors plays a role in the bacterial cellulose yields and thickness. Next, please. Okay, this is the thickness of the bacterial cellulose, which is produced from different sources of agro-industrial or agro-waste. The left one is the bacterial cellulose with carbohydrate content, 58% produced in cassava with water. And the right one is the carbohydrate content. The carbohydrate content is 90% obtained from rice wastewater for bacterial cellulose production. Here we can see that the thickness of the bacterial cellulose production is differ. The thickness is really different. Left side is thinner and the right side is thicker based on the carbohydrate content in the medium. Next, please. Okay. Last but not least, this is carbon and nitrogen content also could be represented by the cellulose and lignin content in the agro-waste. This also shows that depends on the type of the plant, depends on the type of the plant. The cellulose and lignin content are varied. The higher the cellulose content and the lignin content, it proves that the higher yield of the bacterial cellulose production. Next, please. Okay, this slide shows the bacterial cellulose produced in the micro, small, medium enterprises in Cianjur, West Java, using coconut water, which employs at least 12 workers. We have been collaborating with this partner for a long time. We required more bacterial cellulose for novel material. For example, for adsorbent for water purification. This kind of entire activities, I mean the collaboration with other with the small scale enterprises can be categorized as a circular economy activities. So they use coconut water, which is underutilized in Cianjur site, and they produce the bacterial cellulose. Then it could, for them, bacterial cellulose is focused for food purposes. But for us, for example, we can develop it for any other functional materials that I mentioned before. Next, please. This is these examples of the bacterial cellulose application. A review article by Hamada El-Gandhi this year categorized the bacterial cellulose application into 4 groups, typically biomedical, food, environmental, and electronics. Of course, this classification could be enlarged depend on the final target material. But I would like to say that the blue sign I put here, especially I put on the food packaging and glass transparent. Just to recall that these two materials, these materials play a role as an alternative petroleum or fossil-based plastic that commonly cause the environment problem that I mentioned before. Next slide, please. Okay. This slide shows us several samples of bacterial cellulose utilizations, and that has not been mentioned by the previous slide before. Interestingly, this thin and strong BC film was made for this attractive outfit. Know that sometimes we use plastic-based material in this kind of outfit. And then this wearable, okay, this is also based on the bacterial cellulose production. And this is the facial mass production in a large scale based on the bacterial cellulose. And this is wound dressing based on the bacterial cellulose, as well as for the electronics application. And the last one is for art paper. Okay, next, please. Okay, let's move to the lignin resources. Besides the major component in wood and food agriculture residues, and it can be found from macro and microfiber, which is not required if it is directly used, and then it require pre-treatment or severe chemical or physical treatment, especially when they use for a certain purpose. But lignin is also commonly found in pulp and paper industry or bioethanol production. Next, please. Next. Okay. So, but lignin is also commonly found in paper industry. Next, please. Next, please. Okay. So, for example, the chemical treatment as alkalinization or acidification, which is commonly carried out during the lignin isolation. Physical or thermally treatment, for example, as indicated here by hydrothermal carbonization and ultrasonication. Last but not least, fungi is also frequently used for biological treatment, which is considered as the safe treatment. Next, please. The chemical treatment of the black liquor derived from pulp and paper industry or by ethanol production is usually use alkali and acid. That usually used in conventional method. The question is it economically or is it environmentally safe? Because the as like that we would like to use the material derived from these two resources to use it as a new material. But on the other hand, we could, as if we create a new waste. So this is questionable, whether is it really good or not for production, lignin production or isolation. So there must be, we have to consider another isolation technique in order to create lignin that environmentally friendly. But of course, there are a lot of technical that have been found recently. So it is safer to us to produce lignin for craft pulping and pulp and paper industry use this kind of process. Next, please. Okay, the abundant structural features of lignin offer significant potential lignin and lignin-based substance in agriculture and in antimicrobial, in tissue therapy, in lignin healthcare and protection function, as well as in biomass conversion. Excluding in this slide, of course, various other possibilities are also available, such as in automotive, building materials, and many others. With the rapid development of modern technology, as well as in nanotechnology, nanocellulose technology, the generation of lignin nanoparticles provides a new direction for the high-value utilization of lignin. Researchers have extensively studied the application of lignin nanomaterials, such as here we can see in this slide from the nanocapsules, nanosphere, drug delivery systems, tissue engineering, bone tissue, and many others. If you can see from these slides, from the lignin and the lignin nanoparticles utilization, actually the similar product can be generated. So, but the differences lies on the properties and the performance of the final products. Before closing, I would like to, next please. Oh, sorry. This is the product of the lignin that excluding in the slide before. From lignin, we produce precursor as carbon fiber, which is developed for brake pad. This brake pad actually has been developed by using the sugarcane baggies, which we have collaborated with small-scale enterprises in Jatiwangi, where the sugarcane baggies is still underutilized. Next, please. So from the lignin, we can develop the lignin phenol formaldehyde adhesive, which is further applied for plywood production. And this plywood match with Indonesian national standard, so which is also produced from the sugarcane baggies. Next, please. Okay, before closing, I would like again to recall that through the agro-industrial residues, the utilization of these underutilized resources into the new functional material, we not only improve its added value, but also involve in the waste management or related from the related agro-industry, as well as the possibility to create a new job. This series of activities, of course, related with the realization of circular economy. So, as I mentioned before, of course, with the most differences between the linear and the circular economy as lies on the waste production and the linear product in the linear economy, the activity stops in the waste production. But on the other hand, on circular economy, that the activities stops not only in the waste, but we develop the waste to further for further product that useful for next activities. Ladies and gentlemen, I think that's all of my presentation, and thank you.
Okay. Thank you very much, Professor Myrtha, for giving such an informative and comprehensive presentation. All right, all participants. Now we'll move to question and answer session. If you have a question, or if you want to ask a question, please raise your hand and say your name. You can also use the meeting chat to deliver your question or comments to Professor Myrtha. Okay, let me check. The meeting chat. Yeah, the first questions come from Miss Ian Parlina. Yeah, there are several questions for you, Bu Myrtha. I hope you don't mind.
Okay.
Okay, let me read her question. Yeah. The first question about what is your opinion regarding spunbond material that so many companies using it for a replacement or a plastic bag? Because in long time the quality of material is decreasing and seems degrade into microplastic.
Okay.
The second one, okay.
Okay, I will ask.
Okay, yeah, I invite you to answer the first question.
Okay.
Please.
Oh, thank you, Ibu Iin Parlina, for your questions. It doesn't matter if the company use spun-bound materials, okay? Because plastic, as I mentioned before, that plastic is really useful for our daily life. Plastic, especially shopping bag. It is a very light, okay, very handle to bring. But again, if the materials is not degradable, it will cause of environment problem. As long as the spun-bound materials is degradable, especially biodegradable, it's really preferred material replacement as replacement for the petroleum-based plastic. So it doesn't matter. But again, if these materials still come from or generated from the petroleum-based material based plastic, so it will we will have the same or the similar problem to environment, right? So there, as I already explained, that we have tried, many researchers try to find out, to explore the environmentally friendly plastic materials. Okay, so it could be developed from cellulose or lignin. So I would like to say that no matter if the spun-bound materials is produced for plastic materials for shopping bag, it doesn't matter. But now it is important for us to evaluate: is it biodegradable or not?
Okay.
Is it okay?
Yeah. Okay. Let's move to second question. Regarding substitution for polystyrene, since this material is commonly used because it's cheap, price, and lightweight, what is the most suitable biomaterial and technology that could be utilized to replace this material?
what is the most suitable biomaterials and technology? Okay.
Yeah.
Okay. As far as I know, that there are several industry in Indonesia produce biodegradable shopping plastic bag based on the cassava, based on the starch. The starch is either from potato or from the cassava. The question is there any competition between the plastic purpose production or food purpose production? We already know that, probably most of you know that there are non-edible starch could be produced or could be used for the biodegradable plastic. So of course there's obtained by several serious research that has been carried out from a long time ago. But these industries commercially produce these plastic bags, and not only in Indonesia, but even they export to other countries. But the problem is we can hardly find these plastic bags, biodegradable plastic bag produced by the Indonesian industry, because the demand and the demand of this plastic bag is very high, comparable with the production itself. Okay, so the question is, what is the most suitable material could be a potential for the plastic replacement? It depends on the resources available. As I explained before, that in industry, commercially produce the biodegradable plastic by using starch. So it's starch-based plastic materials. And the next questions?
Okay, and the third one.
Is it okay, Ibu Iin? Probably I missed your question. What is the difference? Is it okay?
The third one is, what is the advantage of using bacterial nanocellulose? It is also really economically feasible.
Okay.
Yeah.
Yes, it's a good question. As I mentioned in my presentation, that bacterial cellulose is pure cellulose, only cellulose and water. So it depends on the target material you would like to produce. For example, for bulky plastic shopping bags, it should be considered again, because the cellulose, even though only cellulose and water, it containing of 99% of cellulose, water, but the pure cellulose is only 1 to 5%. So it is really small amount of cellulose, but it's pure. No impurities, no other impurities that usually found from a plant cellulose, which requires chemical treatments for isolation. So because of this small amount of cellulose, for replacement in a bulky shopping bag, of course we have to consider it. So this is the disadvantages of the bacterial cellulose application for the bulky plastic shopping bags. But we can use this bacterial cellulose for plastic for a more functional functional materials, or for functional packaging, or not only packaging but plastic base. If I've collaborated with one of the researchers outside, that we have developed the bacterial cellulose for the light, for the thin, transparent and flexible materials, but not only for shopping bags, but for a functional material. Let's say for we can say for electronics, sensor, not electronics, but for sensor. So because, as I already mentioned, that it's very low concentration of cellulose, where the, even though it's pure cellulose, So we can try to apply this bacterial cellulose for another functional materials, not for bulky shopping bag, as I mentioned before, that dominate the garbage in ocean. So for the plastic application, we should consider about the we have to forget for shopping bag application. Currently, the most that we frequently found in our daily life, that bacterial cellulose is used for food, either food directly for dessert or food ingredients. This is the most frequently used for bacterial utilizations.
Yeah.
Next. Okay, Ibu Iin Parlina.
Iya Bu, thank you. Very clear.
Great. Okay. The fourth question comes from Hana, Universitas Padjadjaran. Prof. Myrtha, in case, asking about circular economy. In case of circular economy, which one is more economic to get pure cellulose? From bacteria fermentation or agricultural waste spiration?
For agricultural?
Yeah, from bacteria fermentation or agricultural waste spiration. Which one is
you mean
economic?
you mean the cellulose production?
Yes.
Okay.
To get the pure cellulose.
This actually quite difficult question, but I can say that as far as I keep in touch with the bacterial cellulose bacterial cellulose production, this could be use industrial residues, agro-industrial residues, either in solid or liquid waste. And then very simple to use to produce the bacterial cellulose. And if in laboratory scale, we usually use acetic acid glacial in order to make the condition of the medium nutrient to the acidity around 3 or 5, right? But in daily activities, actually, there's no acetic acid glacial in a small scale medium enterprises. They just use you know that they very cheap. And then after that, there's no, as I explained before, there's no sodium hydroxide used to purify the bacterial cellulose. They just recently, as I told them that they don't have to use sodium hydroxide, just boil in water, and they do that the application for that. So it's very simple, using the agrobacterial cellulose, agro-industrial residues, and then either the solid or the liquid, and then we just put acid, and then we put the bacteria and incubate it for several days, a couple of days. It's very simple, and the purification also simple. But on the other hand, if we use isolate, of course, there's advantage and of course there's advantages or disadvantages using a product produce cellulose from bacterial cellulose or by agro-industrial residues. As I already mentioned before, that agro-industrial residues requires physical pretreatments, chemical pretreatment, and others. It quite energy consuming, time consuming. So I would like to say that it's really depends on the target materials you would like to produce. If bacterial cellulose, as I told you, that it's very simple, but the cellulose itself, the cellulose content is very small. But especially if it is is used in the dry state, it's very low content of the cellulose itself, but different with the cellulose production from the agricultural residues, especially in the solid form. Even though they need chemical or physical treatment, but the cellulose production is much, much higher. So I can say that it depends on the target material you would like to produce. So there's, of course, advantages, and of course, there's disadvantages of both cellulose production, either by agriculture residues or by bacterial fermentation. Is it satisfied?
Yeah.
Yes, thank you. Thank you, Prof.
Yeah.
It's clear.
Yeah, the fifth question comes from David Julian, asking about plastic production from any fish product. Hello, Bu Karina. Is there a study about the plastic from any fish product? If no, is it possible to produce such plastic from it? Sorry if it was already explained. Maybe I miss it.
Okay, thank you, Pak David Julian. Yes, there is a possibility to produce plastic. I mean, firstly, firstly produce cellulose from, not cellulose, but chitosan. Chitosan is produced from not directly fish, but from marine chitosan. Right, so from the chitosan we can develop the plastic. It is if you search in Googling on a Scopus or any other resources, so there's a lot of scientific publication reports about the plastic from not fish, not directly fish, but from marine, from algae, from chitosan, and some others. So it is possible to produce this plastic. But the question is whether it is commercially produced or not. It is still questionable. Is it okay, Pak Julian?
Okay. I would like to ask one question to Professor Myrtha. Could you please briefly examine the challenges or opportunities, for the development and implementation of the concept of circular economy in agro-industrial residues-based biomaterials in Indonesia?
Yes, I try to explain this circular economy based on the agro-industrial residue in Indonesia. As I explained before, that previously, we practices the linear economy by using the agro-industrial residues. So far, if they just put the waste as a waste, as a residue as a waste, but I found that I just noticed that recently, as also reported by so many scientific publication, that a lot of researcher industry that try to use these agro-industrial residues for new materials. So if agro-industrial residues is classified as a matter of waste, so we can say it is categorized as a linear economy activities. But recently, as I told you, that there are so many activities try to apply the underutilized or the waste or residue from the agro-industry activities, either by from animal, wood, and food, and others agro-industrial residues to produce new materials. So if these activities is carried out, so I think this is categorized as circular economy. that this kind of activities, I noticed that now is frequently carried out in some industries to prevent the waste problem and to add the try to add the added value of the underutilized or the waste itself. So I think the industry, for example, I can say industrial agro-industry, they use the waste, they use the underutilized residues to produce a new new or novel material, functional materials. So because the waste or underutilized residue is not ended in as a waste, and they develop for a new material, they develop to another activity. So I think it is a circular economy. And I think in Indonesia, this circular economy will be as a future economy.
Okay, thank you very much for your answer. Okay, we need to end our discussion session. And finally, I would like to thank the speaker, Professor Myrtha Karina.
Thank you.
Very informative and interesting presentation. And also to all the participants for their active participation. Please give applause for the speakers and for you all. So see you later. And thank you very much for your kindly attention during this session. Over to you, Master of Ceremony. Yeah.
Thank you very much, Professor Myrtha Karina, for giving such an informative and comprehensive presentation. And we would like to present Professor Myrtha with a certificate of appreciation for doing a great job today. Thank you so much.
Oh, I appreciate it very much. Thank you.
Okay, and for operator, can you please stand by to take a picture on my count? 1, 2, 3. Thank you so much.
And thank you very much, Dr. Hanilyn, for being our wonderful moderator in the session. And before we end the session, we would like to present Hanilyn with a certificate of appreciation for doing a great job today.
Okay, thank you for Dr. Handarto, and operator, can you please stand by to take a picture on my count? 1, 2, 3.
Thank you.
Okay, thank you so much. Ladies and gentlemen, we are going to have a short refreshment for an hour. And please return at 1 p.m. Western Indonesian time, and we will continue with our next part of our workshop.
This is Universitas Padjadjaran. Inspired by the vision of the Asia-Africa Conference, attended by representatives of 24 countries, the establishment of the university was the realization of the vision of the cultural figures of West Java to found an institution of higher learning in the cosmopolitan city, to educate and set forth to society dedicated and qualified individuals. Today, UNPAD has broadened its wings to encompass various disciplines and multidisciplinary academic endeavors through the efforts of 16 faculties and 1 postgraduate school. To achieve its mission to build the capacity to adapt and innovate in the face of the rapid development of science and technology at the international level, UNPAD is determined to become the center of research and innovation for the good of the nation and the world by continuously nourishing research and developing technology to create innovations in various disciplines. Currently, 36,000 students are registered at UNPAD, and more than 200 international students are registered in different programs, degree and non-degree. As an effort to constantly improve the quality of education, Universitas Padjadjaran is supported by approximately 2,100 professional faculty members with reputable qualification. To achieve the Center for Innovation and Pharmaceutical Services, the Center for Nanotechnology and Graphene Research, to name a few. Equipped with a central science laboratory network and a science and technology complex in the Center for the Development of Science and Technology on the main campus, Universitas Padjadjaran has risen in its role as a leader in higher learning geared towards innovation. UNPAD also fosters collaboration with other institutions involving all stakeholders.
Universitas Padjadjaran commits in providing benefit and service for the good of humanity and the preservation of the environment. This is a great enterprise which cannot be done alone. UNPAD believes that in the spirit of collaboration, this vision may be achieved. We invite you who have the same vision, a good intention to care for human life and the environment all over the world, to work with us, build collaborations, create a better world together.
Universitas Padjadjaran grew out of the community and has made it its duty to give back not only in the form of the dissemination of knowledge and information, but also through socially responsible activities such as student fieldwork, community outreach programs, and action research seeking to make direct impact on the community. With its feet firmly grounded in the local communities and environment, UNPAD is also making great efforts to take steps towards internationalization. It offers special programs for international students to maintain its global network and make its strategic and reputable place on the world map of higher education. As a site for the personal development of young minds and bodies, UNPAD supports a wide variety of student activities. UNPAD also provides students with libraries with an extensive collection of books, periodicals, and study materials, comfortable dormitories, health and fitness services, free on-campus transportation, and other supporting facilities which UNPAD continuously upgrades and improves. While being committed internationally recognized quality research, UNPAD maintains also its dedication in preserving traditional cultures as the compass for all of UNPAD's activities on and off campus. As of now, UNPAD have set forth unto society 200,000 graduates in various fields of work, including strategic government sectors and crucial multinational industries. Works for the good of society, bringing innovations and sincere contributions to humanity. Universitas Padjadjaran, the pride of West Java, working for the benefit of the global world.
Belum ada tahu. Mana? Mana? Oh iya ada.
Iya, Bu.
Tapi apa duluan? Okay, ladies and gentlemen, next session will begin shortly. Thank you. Our session is about to begin. Please turn off your mics, turn on your camera, and change your name format.
Ladies and gentlemen, without any further ado, we will now begin our next session. Our next agenda will be talking about an emerging tree of life.
This session will be led by a moderator, and our moderator for this session is Dr. Nanang Masrudin. Allow me to read his short bio. Mr. Nanang Masrudin is a research professor and administrator at Research Center for Biomass and Bioproduct, Natural Research and Innovation Agency, or you can call it BRIN. His research interests are in cellulose nanofibrous isolation, bacterial cellulose, cellulose modification,